The next session will be taken by Shri Suresh, Chief Research Engineer and Head of Air and Gas Flow Laboratories at the FCRI, that is the Fluid Control Research Institute. Sir has over 25 years of experience in calibrating and testing pipe of flow products, gas flow meters, site calibration, metering speed validation, designing and developing special application flow meters for metering methods, and gaining model approvals of flow meters for flow products. Today he will be delivering a talk on testing infrastructure in India for domestic gas meters. So I kindly request sir to share his slide. Okay, he has already shared. So sir, you can please start your presentation.
Yeah, thank you. So my slides are able to see?
Yes, sir, it is visible.
Yeah, thank you, sir. So I'm CB Suresh, and I'm very thankful to BAS for giving me an opportunity to be part of this wonderful session with the best available experts in the panel and the audience. So I'm sure most of you must be aware of FCRI, Fluid Control Research Institute, Palakkad in Kerala, situated the southernmost states, one of the states in India. They are pioneers in fluid flow measurement and calibration activity. This was set up with the UNDP 8 in 1989, and by that time there were no experts, reliable experts in our own country to have or to make a setup regarding the fluid flow. So this was set up by the UNDP assistance and Government of India assistance, and we started functioning in calibration and testing of various types of flow meters. So we have basically many different laboratories, of course, in different media like air, water, and then in oil, water and oil in liquid medium, and at present air in gas medium. We are looking or developing something in natural gas also, but it may take time because of some unexpected hindrances in the development. It is slightly delayed. So coming part of the airflow facility, we are one of the best facilities available in our country, which are experienced by many of our colleagues from different manufacturing units, users, and flow meter developers, end users, etc. Most of the manufacturers, they already used our facility or being used our facilities. One of the facilities which are at par with many international standards also, those who are participated in FCRI and many other different laboratory. The accuracy what we claim and the within our range, it is at par with many other foreign laboratories. And at present, we do extend our service to many countries outside India. Some of the tests it is including Middle East, then some of the Israel, Scandinavian countries, so USA. So many manufacturers from across the world, they use our facilities. Coming to the today's subject on this one, something related to the gas flow measurement. We have testing of diaphragm gas meters as per BS standard, OMS standard, and IS standards, testing of turbine RPD meters as per different national or international standards. We do model approval test of diaphragm gas meters and associated regulators also. We have the facility at close to atmospheric pressure. We can start a flow rate of 1 ml per minute to about or slightly more than 10,000 meter cube per hour. And at an elevated pressure up to 20 bar, we can cover the range up to 400 meter cube per hour. So many of the CGDs companies in their distribution or measurement flow meters are being used our facility, high pressure and low pressure airflow facilities. And along with the flow measurement lab, we have all other associated parameters also can be calibrated instruments like pressure, temperature, current, voltage. So flow, vibration, noise, flow and related parameter, we are one of the largest laboratory in the world itself. And our accuracy is also very close to international levels. And that is definitely by the help of our users and our government and the visionary of our earlier engineers and other government officials. We do validation, calibration of flow meters installations, and if any specific problem is identified by any of the manufacturer, any of the user at the site or manufacturer after installation, we extended our service to resolve those issues from the field study and then developing some metering techniques which are suitable to that particular application. So many such installations have been done, installed, and validated. So these are some of our area of work. Coming to the gas, domestic gas, we did the first model approval in almost 20 years back. Unfortunately, the first few companies who have taken model approval from our end is not there in the field now. So diaphragm gas meters, it starts from G.6 to G650. But as many of our experts told, in present Indian condition, G1.6, G2.5 is the most populated ranges. And of course, earlier G4, G up to G25, G40 was also being used in industry. But considering the accuracy of the meter that can serve, it's slightly inferior to some of the new technologies, and slowly some of the industries, they have shifted from different type meters to rotary type meters, considering the better accuracy and higher pressure, operating pressure. And why a model or type approval is necessary? That is, if any manufacturer, if they produce any new meter, how to give a confidence that that particular model is capable of metering to the national or international levels, accuracies, and the government body can accept that manufacturer. So in Indian government directly under, they do not have any laboratory. So now they depend on other laboratories and they do the testing, and then after the test they share the certificate with the approval agency, government agencies, and based on the certificate they accept that particular model. So new and upgradation of the models are keep on happening, and once any changes are involved, a new technique is being adopted or any attachment is there, it should be validated through proper test. And our present Indian standard does not cater to many of these stringent tests which cover in some of the foreign lab standards. Minute. Earlier we have presently also we have IS standard 14439 which is under revision now, and OML R137 and BSEN 1359. After this one, OML R137 is general recommendation for all types of flow meters which depend on different principles of operation. And IS standard is typically focused on diaphragm type meters, and EN 13959 also focus on diaphragm type gas meters. So if you compare the Indian standard, old Indian standard and the BS standard, the BS standard recommends much or many more tests which are more realistic to the operating conditions than our Indian standard. And now I congratulate the BAS to adopt or make a revision to the standards, that our standard is also in par with the international developed countries standard what they follow. So we are in the process of upgrading many of the standards. So we are happy that we could also take part in this aspect in 1359. So basically it covers error of indication. So many tests which are described by many other panelists earlier. First model approval test we did, first 2 or 3 model approval test, it was not on based on Indian standard, it is based on EN 1359 standard. So at that time itself, the manufacturers were having the feeling that following the developed available acceptable standard, which may be superior to the national standard, will help them to cater to the future also. At that time, it may be it was, I think, at least 18-20 years back. So after that, they have withdrawn from the market due to many reasons, and now many manufacturers are available in India. They import directly the whole unit or import the components and then assemble here. However, whatever is the procedure, it should be and the meter produced or the product should be validated by any Indian agency. Now, apart from FCRI, there are a few more laboratories who are capable of doing this test. These are all some of the tests what we do, and these are so 137. These are all few tests, and EN 1359 being exclusively standard for diaphragm gas meter, it explains it to cover many more tests. These are all the tests earlier FCRI was serving. Of course, we don't claim that all the tests recommended by the standard is able to cover by FCRI. So we focus or cover most of the tests that related to flow and related area, and remaining few tests for casing, metallurgy, and for the rubber and the casing components. Of course, they have to depend on other laboratories to get it certified and then submit all the certificate together to the legal metrology for acceptance. Basically, the ambient temperature requirement as per the EN standard, it is compare 4 temperatures, and the 4 temperature is where the meters are kept for testing, and what is the ambient temperature, what is the temperature of the fluid passing through the meter, and what is the temperature in the reference standard. From the all places, the temperature should be within 2 degrees centigrade, and ambient conditions, variation in ambient condition over a period is 4 degree or 4 Kelvin per 12 hour and 2 Kelvin per hour. But at present, FCRI is capable of maintaining the temperature within 0.5 degree centigrade throughout the test, considering the temperature at the meter at the reference system and where it is being stored. Bellprover, one of the best reference standard, which is also covered by the EN standard. We have a Bellprover of 500 liter capacity, and now the claimed BMC is 0.1 percentage. When it was supplied, it was 0.2 percentage, and over that we improved the accuracy by changing the scale from mechanical scale to digital scale and a better calibration method for determining the volume. The accuracy has been increased from 0.2% to 0.1 percentage. And at the lower range, we have another Bellprover, but accuracy is slightly inferior. It is 0.3 percentage. And to the very low flow rate, we have a piston prover, which is 0.2 percentage, and flow rate can come down to 0.0012 meter per second. And for testing, endurance test and all, we have a small test bench which is developed in FCRI itself. We can accommodate 10 meters in series. And in this one, we can connect Bellprover or we can connect critical nozzles. So different standards can be connected depending upon the flow rate it is required, and we'll select accordingly. the test bench. For different types of test, like spray systems, different climatics, we have climatic chambers where we can vary the temperature, humidity, etc. For different to generate different climatic conditions, and of course we do some of the tests using these chambers. We have a shaker also. At present it is showing a scanner, application, but in the same a smaller shaker is being used for vibration and vibration measurement monitoring system for diaphragm gas meter. This is some one particular result what I want to share, because standard says the accuracy over 6 continuous cycles of operation. So how the error curve that is varying, that can vary, that again will depend upon the manufacturer or model. So 1, 2, 3, 4, 5, 6, you can see that this is a particular result what we have observed. Though the pattern, accuracy pattern is different, it is within the acceptable limit. This is very interesting for the manufacturer or developers, how it can vary in, and that will help to select the material of diaphragm and other hinges and other counters. And then we do the torque test. So these are all relatively simple tests. We can have the torque test and bending moment test, resistance to impact. These are all the things we developed in the beginning, because we were also very new to this requirement, and all of a sudden if someone is approached FCRI that we want to have a model approval, that in our country that implementation of standardization has been started. So earlier it was imported, and then our CGD, the pioneers in that field, they will deploy the meters, and over a period of time our nation want to have a tested and validated flow meters, and when they approached, it was defined, everything was developed within our knowledge what is to be done. So every time it is a new challenge for us to devise it and then test it. And the impact of one of the manufacturer who was not there in the present, from the impact test 2 times, this is the third time he could pass that particular test. So that time it was really interesting, and why that test is so important, because many people asked me why that important test is very important. So after doing the test, and then initially the manufacturer also could not believe that he is also following some international standard, but due to the type of material he has used, so 2 times his product failed in that particular test. The third time only you can succeed by changing the materials. So this is showing how important a standard is, and the test criteria also, that our manufacturers, users, our law-making agencies, how to make a particular law a standard, and how the manufacturer deal with the standard, and what an end user expect a standard. So without this testing and experience, we will not be able to understand many of the requirement in the standard, whether we should follow it or not. So really it will help us to improve and reach to a higher level. So nowadays our manufacturing units are also looking for export of their products. So from the import side, we are starting to export side. So many of the standards which we are having may be insufficient to the international market, but now by adopting the international well-known standards to India, which is suiting to the Indian conditions, and which will help us, the manufacturers and the testing agencies also, to test it and help the manufacturers to export their units. So I just shared a very small information what FCRI could do and what FCRI was doing. So with that one, I want to conclude my session. So anything regarding FCRI, you can ask me.
Thank you very much, sir. And yeah, you have explained the various test methods that are required in gas meters and all your studies that you have done to improve the accuracy of equipments, certainty of the equipments there, FCRI. And also you have given an insight that what are the best models for getting the better accuracy in India and importance of the impact test and top test. Thank you very much for your presentation. And now I will request all the panelists to start the discussions with our attendees. What I will do, I will invite some of the attendees who have raised some questions to discuss, and I will request the panelists to answer their questions. So just whoever wants to directly interact with the panelists and BIS, they can raise their hands